Hello everybody, in this video I will be talking about foreign key constraints, and these are actually pretty cool. But first I want to give an example. So let's say in our imaginary world we have a database for customers of an online store, alright? And then there's also orders. So customer 6 ordered a bicycle and a new hat. Alright, so let's draw this out. Here we have a table. Now, let's say also we can leave comments on the website from certain customers. So here's the customers. And then we also have a table down here for the orders. That says orders. And we also have a table here for comments and reviews of products. So each one of these is going to have IDs. So this will have a customer's ID, order's ID, and comments ID. Now also, since these have, for each order we have who bought it, we will also have a customer's ID here, which will be a foreign key back to customers. So this will come back up to here, and then comments will have a who it's from. So these will also come back up to here. So if you look at it, it's sort of like a branching system. So these both point back to the customers. And then the foreign keys, so we have the ID here, the ID here, and the ID here. And these are all supposed to be the same person. So here we have a little guy. His name's Caleb. And he goes to this website daily and buys stuff. So his customer ID, he has a customer ID of 6, right? Let's not use that number. 7. So now, when he buys something, he has another order number of 7. And then when he leaves a comment, he has another 7. So now you can see these are all the same ID. So the 7 all refers to Caleb. And this is how it is all connected to know who is who. So if you need to know who is customer 7, you look at the customers table, because it's going to display all the information about customer 7, whereas these tables are only going to say the customer ID. So if you look at this is sort of like the mother, and these are like the children I should say, sorry. And the IDs, the customer IDs, are foreign keys. So now let's say, in our imaginary world, this guy breaks the law on the website and gets his account deleted, right? So, no more Caleb. He's gone. So customer ID 7 is gone. So now, let's say his information in the table is gone for the customer's table. The table's still there, just his information about it is gone. So now, we have an order with the ID 7 and a comment from the ID 7. Or a review from the ID 7. So who does this point to? Oh, let's go look at our table, and whose ID is 7? Oh, it's not there. You know why? Because Caleb got deleted. So now we have comments by people who don't exist, and this isn't good. So the purpose of foreign key constraint is to prevent this. So basically, let's say we have a table with the information of Caleb, and then when the information gets deleted, say, the information here will also get deleted. So now, we don't have any orders by Caleb, or this person who doesn't exist, except for history, like he at one point in time, this guy bought this, yeah. So there's no comments by him either. So now, we don't have anything about Caleb, which is what we want because he's gone. There may be times when you don't want this, and that's why there's some more options for constraints, and that's what I'm going to be talking about. Here I wrote a whole bunch of stuff, but don't freak out because I'm going to explain everything here. Now first, I want you to remember what our database looked like. We had a table here, which broke off onto 2 tables. So this was sort of like the mother, which this will be the customer info, then we had the orders, and then we had the comments or reviews of certain products that was on the website. So let's look at this. when you create a new table, first we would create the customers table, since it's like the mom, in theory. So the customer info table, and then what we would do is we would create foreign keys on these two tables back to this single table up here. You get the point. Yeah. So in order to do this, we would first create the mother table, and then when we create this, we would define a foreign key in the query. So you would say the foreign key, just like you write primary key before to define the primary key. Well, now you're going to write foreign key. Now, what is the foreign key's name, or what's the column name? It would be customer ID, which will be a foreign key. So even though it's a foreign key, it's still a column within these tables. So you would have a order ID, and then you would have a customer ID, or a cust ID. Now, what does this customer ID, what does it reference? It references customer info, which is a table, and then it references the column customer ID. So here we have the table customer info. So this here points to this table right here. Can you see that? Yes. And then which column does it refer to? It refers to the customer ID. Or this is actually the primary key of this table down here. Because you remember, the table's customer info, and every single table needs a primary key, so the primary key will be customer, or cust ID. Doesn't really matter. You can name it whatever you want. Now, when you do this, this makes a connection. Now, by default, if you don't say any of this extra stuff and you try and delete this, it'll give you an error. Or if you try to change something, it's gonna prevent you from doing this. It'll give you an error. So if you want to break it up more, there's two options: on update, on delete, and then you can put two things after it: cascade or set null. There's some others, but these are the main ones. So what does this mean? Let me explain these first. Cascade, this will do whatever you do to the main or the mother table will affect the children. So if I delete this table and erase it, these two will disappear too because they reference back to that. Set null, let's say if I delete this table, it'll actually go and set these tables, the information for Caleb, to null. If you remember our little guy, Caleb, if we erased him, the new information will be null or empty. So this is our options. So now which one points to what? On update, if you want, let's say you update it and you want it to also update it in the children tables, then you would use cascade. And if on update you want to set everything else to null that you've changed, then you would use set null. So for on update, I'm going to use cascade. Right? Now on delete, we can set it to null, and think about this. If the table or if the column has the feature not null, then this will also give you an error because we can't set it null. So we're also going to use cascade for this. So let me explain this a bit more. Let me erase this real quick. If we update the mother table, it's going to affect all the children's tables. Children table. All the yeah. And if we delete the mother table, it's also going to delete the children's tables. So this is going to protect our database structure, or integrity, or whatever you want to say. It's going to protect it and keep it so there's not going to be stuff that points to things that don't exist. And this is all called foreign key constraints. And also, this must be on the database engine, storage engine, InnoDB. So if you remember, we had MySQL. Let me write these out. I think it was MySQL, and then we had InnoDB. This must be of the storage engine InnoDB, not this one. This is for full text searches, and we will be getting into those soon. So keep watching, and I'm hoping you're learning a lot because this is actually some pretty interesting, and this is actually starting to get more advanced So I'm glad you're sticking with me this far, and I'm hoping you're learning. And subscribe and let me know what you think, and like my video, and add me on Google Plus, and share it to your friends, and that's all. Oh yeah, subscribe. See you later.